What's up, everyone? This is LeetCode 3, longest substring without repeating characters. So we're given a string S, and we have to find the longest substring without repeating characters. And a substring is a contiguous, non-empty sequence of characters within a string. So make sure you understand the difference between a subsequence and a substring, right? EWKE in this example is a subsequence, but it's not a substring. So in this example, right, the longest substring is actually WKE, right? There's no repeating characters in it. Whereas PWKE would be a subsequence, but that's not what we're looking for. We're looking for substrings, okay? Now initially, when you encounter this problem, you might think the best way to approach the problem perhaps is to check this, right? Check this, check this. Oh, we have a repeating character. So let's go here and check this and check this. Oh, we have a repeating character. Let's check this, check this. The problem with doing this, of checking basically starting at a letter and checking all the combinations until we get a repeating character, and then moving on to the next letter and checking every combination, is that we add a lot of overhead, right, with checking if there's a repeating character. Because, and the problem with that is that our string length can get pretty big, right? So we want to reduce as much overhead as possible, or we're going to get TLE, right? Time limit exceeded. And that's not what we want. So there's actually a way to solve this problem in one pass. And essentially what we're going to do, the gist of it, is we're going to basically have a sliding window, right? Like this, then like this, then like this. Okay, now we have a repeating character, right? An A here and an A here. What we're going to do when we have a repeating character is just move the left side of the window over one. Okay. Okay. Oh, another repeating character. Okay. This over. Oh, another repeating character. Okay, move this over. Oh, another repeating character. Oh, another repeating character still. Right. Okay, nice. Move this over. Oh, another repeating character. Still a repeating character. Okay, now we'll move the right pointer over. We're out of bounds, right? So we would terminate the loop. And the longest substring we would find is ABC, right? Or BCA, but like, ABC is the first substring we found of length 3. But we're not actually returning the characters, we're just returning the length. So we'd return 3. But, right, ABC or BCA, doesn't matter. They're both 3 anyways. Down here, right, same concept, right? Move the right pointer over. Okay, oh, a repeating character, right? Oh, we still have a repeating character. Okay, move the right pointer over, move the right pointer over. Okay, longest substring we found so far is length 3, WKE, right? Move this over. Oh, repeating character with its W. Right, this KEW is also length 3, right? Just like this WKE. So it doesn't really matter. I mean, length 3, right? But point is, like, the longest one we found so far is length 3. And then we move the right pointer over. Again, we're out of bounds, so we exit the program. Okay? That's how we're going to do that. And the way we're doing this checking programmatically is we're basically this right pointer when we're at a character that's not in our set, and that's how we're going to keep track of unique characters, to keep track of which characters repeat, is we're going to use a set, right? Because sets can be unique. They have to be unique, right? So when we encounter a duplicate character, we basically just check, is this character that we just got to in our set already? If it is, then we know we have to move the left part of the window. Otherwise, we move the right. We add the character to our set. If it's not in there already, and we move the right part of the window over. Okay, that's really how we're gonna do it. It's pretty simple. Okay, this is a medium problem, so I assume you've done a few easy problems with sliding windows, so you kind of understand the gist of what we're gonna do here. So that's why I'm not trying to go super slow with this video, because I assume you're at least decently competent at some of these problems, considering this is a medium one. And you know, if you've been following along on Grind 75, we have done problems already with sliding window, easier problems. So really, this problem is just understanding and knowing the trick, but like the actual implementation isn't hard. It's just like actually thinking of the implementation is the hard part, right? Like coming up with it. But like reading the code and understanding it shouldn't be that hard. We're gonna have a right pointer that's gonna move over, and the reason we're gonna say while the right pointer the right while the right part of the window is in bounds is because the left part would never be over here while the right one's over here, right? So we only care about this part being in bounds because this part will always be to the right of the left pointer. So when the right one goes out of bounds, that's basically when we exit this while loop and return the count, which is the length of our substring. Okay. Or the length of the longest substring with our repeating characters. So we're basically going to say if the right pointer is pointing at something that's not in our set, then let's add it to our set, right? So we're going to say set.add sub r, move the right pointer over. And this is where we update the count, right? The way we update the count is like, right, let's say we're here. We add p to our set. We're basically going to take the length of the set, which would be 1, and compare that to what our count variable is at, which initially is 0. So 1's bigger than 0, so our new count would be 1, which makes sense because this substring p is bigger than the initial substring of 0. In the next step, right, we would add w to our set, and this length here is 2, and that's bigger than 1. Makes sense, obviously. Okay, so the way we're going to do this, we're going to say count, and we're going to take the max between count and the length of our set. Okay, initially you could basically just do, you know, r minus l, because when we add stuff to our set, we're moving the right pointer over, right? So this would be 1 minus 0, right? And this window is of length 1. So because even though we're moving the right pointer over at each step, we're not actually accounting for this until the next iteration, right? But we'll just do it this way, right? The length of the set, you can do it with whatever, you can count the window manually or just do length of the set, whatever you want to do, it doesn't matter. Now else, and else would be the case where we encounter something that's already in our set. So for example, when we hit the second W, that's the part where we have to move the left pointer over, right? But before we move the left pointer over, we have to remove the character the left pointer is pointing at from our set, right? Because we're moving the window over. So we would do sub L plus 1. That should be it. Okay, pretty simple. Now, additionally, I am using a while loop, so I'm moving these variables manually, or these pointers manually. You don't really have to do it like this if you don't want to. I just think it's more readable for somebody who's encountering the problem for the first time. But you can just do it like, right, L is equal to 0, count set's equal to set. We can just say for r in range of s, right? Right, and then outside of that, we're adding stuff to, or this is a case where we encounter something not in our set, so we do my set dot add star, we do the count thing, or do count is equal to count r minus l plus 1. We would do plus 1 because we're not actually moving the right pointer over before handling. We were not in my original solution, I'm moving the pointer over before I handle. I'm moving the pointer over, but I'm not handling that specific letter until the next iteration, right? So in my example, you would do my r minus l, but in this case, you would do r minus l plus 1 because we're not moving the pointer over just yet. So you need to add the plus 1 to make sure the window's of the right size, right? Just think about it visually; it'll make sense. I think you understand what I mean. You can implement this problem a few different ways. Just make sure it's efficient, right? So I guess I'll explain this in case you're still lost. What I'm saying though is in my solution, right? In my solution, our our pointers are, I'm handling this letter, but moving the pointer over, but I'm not handling this just yet. So in my solution, you could do r minus l, which would be index 1 minus 0, and you would get 1 to handle this window size here of 1. So even though my right pointer is right here, you don't need to do r minus l plus 1, because we're only handling this right now, not this. So I hope that makes sense. Next iteration, when we start the next iteration, in my original example, or my original solution, then we handle where the right pointer is already at. That's what I mean, okay? But anyways, that's just, I think you understand. I don't want to go into too much detail, but I just over-explain things sometimes because I don't know if people understand what I mean or not, but this problem, really not that difficult, I think. I think the only difficult part is making sure you understand why we're using this approach rather than the long way. It's because this is one pass. And, you know, sliding window is not new. We've used it before. The only thing that's hard about this problem is knowing that you're supposed to use a sliding window, but I guess because the sliding window really, like, maybe it's kind of obvious considering it's a substring problem, but like accounting for the repeating characters, well, the way you do that is use a set. Maybe this part's hard to come up with, right, on your own. Intuitively, like, to know, oh, let's use a set to account for the duplicates in our sliding window, right? That's a hard part, but I think the solution is actually pretty easy to understand. But yeah, I hope this helped, and I'll see you in the next one.